The control part clamping screws are now tightened. If the air plug or its friction ring are worn, both have to be replaced. Remount the retaining disc and tighten firmly. Now replacement of the control part is completed. We can now reinstall it completely. These replacement steps are almost identical, except for the sponge pusher, to those of the body cylinder. Now to the roller levers. The rollers must be round and cannot have any flat surfaces. If the roller or bolts are worn, both have to be replaced. The roller must not have any play and should be easy to move. When mounting the roller levers, check the spacers so that the roller corresponds to the cam height. The spring is easiest to attach when the roller is at the lowest point of the cam. The same procedure for the remaining roller levers. Finally, the sponges are checked for wear. If the sponges are worn, as on this gripper, a high-quality labeling is not possible. In this case, they must be replaced. The sponges are removed from the metal. The surface of the metal is roughened. The sponge metal is coated with Bostik primer in order to later achieve a better adhesion of the glue on the metal. After the primer has dried, the metal and the sponge are coated with Bostik contact glue. After approximately 10 minutes, the sponge and metal are glued together in the correct position and briefly pressed together firmly. For sponge plates fastened with screws, a glowing wire is used to burn holes through the sponge. Consequently, maintenance and wear testing are now completed. We can turn to the adjustment. The adjustment of the gripper cylinder begins on the machine. Before the gripper is placed on the aggregate, we tighten the clamping screws of the polygon hub slightly. The gripper cylinder is fixed at the correct height using the corresponding spacers. The gripper is rotated on the hub until the anvil, by and large, coincides with the leading edge of the pallet. The anvil is now set to the pallet so that there is a 1 to 1.5 millimeter gap. The gripper hub is set correctly if there is a 3 millimeter gap between the pallet edge and the center of the anvil. We now check if the gripper fingers are horizontal and centered in the pallet notches. By rotating this gripper segment past the pallet, the anvil gap, finger position and gripper hub setting are checked again. If everything is okay, all screws on this segment are tightened. This segment serves as a reference and must therefore be marked. When lifting it off, be sure that the hub of the gripper cylinder is not shifted. It can now be tightened. Now the settings of the reference segment are transferred to the other segments using an adjustment aid. Here is the part number of this assembly. First, the anvil radius is scanned and transferred to the other segments. Now the height of the finger on the reference segment is scanned. Then the fingers are set flush with the anvil. This setting is transferred to all other segments. Be certain that the gripper finger, pushed in with the thumb, is flush with the anvil and fits in height to the stopper. When tightening the screws, do not let the finger slide. Now, both fingers should lie on the anvil bar simultaneously. If this is not the case, the clamping screws of the spring parts must be loosened. For adjustment, we use our thumb to press both fingers onto the anvil bar and pull in the spring parts evenly. When checking the contact time point, the roller lever serves to move both fingers. Thus the fingers are opened slightly and the roller lever is temporarily clamped. The label test confirms the correct adjustment. This contact surface is larger in gripper cylinders with just one finger due to the use of plastic anvil bars. Therefore, special importance is placed on the fingers lying plain on the anvil. The imprint of the finger can be made visible with the help of a foil. In case of uneven contact, as here, the finger must be bent to the correct position. And now for comparison. Correct contact looks like this. Back to the body gripper. We now set the tension of the gripper fingers. The cam lift is measured with a vernier caliper. 2 millimeters are subtracted from the measured value. The result is the dimension of the spacer to be used, in our case the head of an 8 millimeter hexagonal screw. This is placed between the inner pitch circle of the cam and the roller. The gripper finger is pressed on the anvil, the lever clamping screw tightened. After the finger contacts the anvil, the roller lever must slightly overpressure the spring part so that the gripper finger has about 1.5 millimeter compression. Last but not least, the sponges are placed on the gripper. If they are too loose, we must bend the clamp slightly. Then the gripper is placed on the aggregate and the closing cam adjusted. We now determine the point where the gap between anvil and pallet is at its narrowest. Right at this point, the gripper finger must contact the anvil. The control cam must follow accordingly. The clamping of the control part is loosened. Should the clamping screws be inaccessible, remove the brass retaining disc. For the time being, it is sufficient for 2 screws to be tightened slightly until all adjustments are completed. In this position, the sponge must not come closer than 3 millimeters to the pallet. If need be, the sponge must be grinded accordingly. For plastic anvil bars, the anvil should be as parallel as possible to the pallet contour at the closing point. If need be, install the anvil bar with a different slope. In order to set the opening cam, the aggregate drive must be tightened again. For this, we return the cross slide to its original position. And rotate the pallet turret until the mark coincides with that on the bottle table. And then tighten all screws on the universal joint shaft firmly. In order to set the transfer of the label to the bottle, we determine the center of the label on a gripper segment. The label is folded, fixed, and the center is marked on the gripper sponge. In order to transfer the center of the label to the center of the bottle, the machine is inched to the transfer axis. The gripper shaft must line up with the centering bell and the main column of the machine. The mark on the sponge should now lie exactly on this line. If this is not the case, the position of the aggregate must be corrected by opening the universal joint shaft. Now the opening timing of the gripper fingers will be set. The label is fixed in the correct position and coated with a little bit of glue. The finger should open in the moment when approximately 1/3 of the label's surface is pressed on the bottle. If this is not the case, the opening cang must be adjusted accordingly. Be careful that you do not shift the closing cam. For setting the air blast, the machine is inched until the finger is open to about 4 millimeters. The plug support is removed. The opening of the air channel must be in the center of the support. We do a blast test in order to ensure that this opening belongs to our segment. This is also an operational check. Now we do a complete check in order to ensure that another cam was not accidentally shifted during the many adjustments. Especially important, the timing of the closing and opening of the gripper fingers. The body gripper is now set. And now to the shoulder gripper. The adjustments are basically the same as those for the body gripper. However, the shoulder gripper has an additional sponge pusher. For this adjustment, the gripper shaft, centering bell, and the main shaft of the machine are lined up. In this position, the roller of the sponge pusher should be at the highest point of the pusher cam. If this is not the case, the clamp is loosened and the pusher cam adjusted accordingly. The timing of the opening of the fingers is set just like on the body gripper cylinder. For shoulder labels, pay absolute attention to the secure position of the label when the fingers are open. The rule that 1/3 of the label surface must be pressed on before opening is true here as well. After these adjustments, the gripper cylinders are removed and all clamping screws are tightened firmly. The remaining components, such as air blast, lubrication line and optional label blasting, are now remounted for the trial run. The basic adjustment of the aggregate and the gripper cylinder is thus completed. We turn to the third part, which covers the operation check using glue. See you in part 3. In part 1 and 2 of this series, the basic adjustment of the aggregate and the maintenance and setting of the gripper cylinder were covered thoroughly. We will now handle the operational check using glue. We will continue from the point where we stopped in part 2. This means we complete the aggregate with all protective assemblies. The first thing to check during the test run is the gluing. In the 0 position, there must not be any glue film visible on the roller. If, however, a glue film does exist, we correct the setting of the scraper using the X center. Now, by activating the lever for pre-gluing, a thin glue film can be applied in which the palette imprints must be visible. This imprint must correspond to the shape of the palette and be absolutely even. If a corner should be missing, it can only mean that the palette is bent. However, if an entire side of a palette is missing, then its path of motion must be readjusted as already shown in part 1. If the gluing is okay, we can continue with the setting of the label magazine. First, the penetration. The pallets must push the label stack back by approximately 1 to 2 millimeters, depending on the size of the label. This adjustment can be changed at 2 different points. First, the basic setting of the whole label magazine carrier using this adjustment feature. This affects all label magazines. Second, The alignment of the magazines of one dressing with respect to one another can be done using the fastening screws of each magazine. There should not be any shifting of the foremost label during the removal of the labels. One of the causes for this error could be a slanted label magazine, which can be checked easily by simply measuring parallelism. And/or too high a pressure from the label follower, which can be changed by adjusting the tension of the spring-loaded roller. Here, a proper removal. Now let's check if the label is placed neatly on the pallet. We take a pallet out immediately after label removal. The label should protrude over the pallet edge by 0.5 millimeters everywhere, thereby preventing the spreading of glue. Now the label removal by the gripper cylinder will be checked. Please pay attention that all gripper segments remove the label reliably. The label blasting must blow the label onto the middle of the gripper sponge in order to hold it stable for the transfer. The label transfer is now checked using a few bottles. It is done before the brushing on step in order to exclude possible impairment. Here, the exact and precise position of the label must already be guaranteed. In order to prevent the brushes from shifting the labels, the bottle with the label must run into the brushing on station centered. The brushes must brush the label simultaneously with even pressure and corresponding to the bottle contour. The final check is made at discharge. All bottles are now checked in order for slanted, shifted and damaged labels. We have now completed the operational check using glue and will continue on to the next and final part, troubleshooting. In parts 1 and 2, the basic adjustment of the Krones labelling station was shown. In part 3, a general operational check using glue. In the fourth and final part, we will cover troubleshooting. The tips and tricks we want to show are based on the knowledge gained from the first 3 parts. If the labels are slanted, we basically differentiate between three types of errors: the repeated error, the continuous one, and the random error. A repeated error is when the interval between the errors, as here on every sixth bottle, is identical to the pitch of the gripper, pallet turret, or discharge star wheel. It can be traced to this part of the machine. When the machine is stopped, the faulty segment can be determined by counting back to the star wheel or aggregate. If the label is glued on only one side, the path of motion of the pallet should be checked. If there is no glue on one of the corners, the cause is usually a bent pallet. However, if a gripper segment is involved, it can be the condition and adjustment of the anvil bar, contaminated gripper fingers or their adjustment, a sponge which is badly worn or whose shape differs from that of the others, and in case of grippers with pushers, a broken spring, for example. The sponge would then be strongly contaminated with glue. If repeated errors occur at half the gripper pitch after the universal joint shaft has been exchanged, the alignment of the upper and lower universal joints of the cardan should be checked. This is also indicated by markings. Now to continuously slanted or shifted labels. The position of the aggregate with respect to the bottle plays an important role. Therefore, for each bottle, the cross slide must be positioned at the corresponding marking on the machine. Frequently, an error source for slanted labels is too much glue. The labels can then be shifted in the brushing on station. Easy to check at the discharge, the label must not float, as shown here. A slanted label magazine is most easily detected by the label straight on pallet check. If this is okay, the centering of the bottle on the bottle table before transfer is then checked. The bottle must not move when the centering bell is lifted. The operation of the gripper is checked before the brushing on using a labeled bottle. The label must already adhere firmly to the bottle and must be neither slanted nor shifted. If the bottle is okay, the brushing on station or the discharge bottle guide parts could be at fault. If the body or shoulder label are not positioned correctly before being brushed, the gripper adjustment must be checked. The spacing between the anvil and pallet should be specially checked. Also the finger adjustment using a label. If only the shoulder labels are slanted, the following principle is true for the setting of the cross slide. The aggregate is driven toward the bottle so that about 1/3 of the label surface is pressed on by the gripper sponge. The position of the screw for these bottle guide parts at the stop pin should be corrected if necessary. The cross adjustment, the left-right adjustment of the cross slide, provides an optimal transfer of the shoulder label onto the conical part of the bottle. If the shoulder label is slanted, its position can be straightened by adjusting the cross slide. Rule of thumb for adjustment: the aggregate is always adjusted in the direction of the higher edge of the label. So, if the label is higher on the left, the cross slide is moved to the left. If the label is higher on the right, adjust to the right until the label is straight. If the universal joint shaft develops a little play after longer operation, and therefore the label is slanted, this can also be corrected by the cross slide. The new position must then be registered in the marking table. In case of major deviations, the adjustment of the shoulder gripper cams must definitely be checked. The removal from the pallet, the center position of the sponge pusher, the transfer of the label onto the bottle, and the air blast, which is supposed to blow the label away from the anvil and not blow it onto the bottle. From the slanted labels onto the damaged ones. The position of the damage on the label usually reveals the source of the problems. The position can be identical to that of the label prongs, gripper fingers, or bottle guide components. If the label prongs are the cause, first check the adjustment of the label guides with respect to the label size. Careful about possibly dried-on glue residues. The prongs must be centered in the pallet notches so that the glue will not be transferred. If the pressure of the tension roller is too large, the labels will be pressed too strongly against the prongs. If the pallet's penetration is too small, the label is not pressed free of the prong's back edge. In both cases, the label is damaged during removal. For sensitive labels, the shape of the prongs may have to be adapted in the direction of removal. Here you have to file. Prefabricated prongs are available at Krones and may only have to be optimized. Otherwise, they are shaped from an unfinished piece. The prong must slant upward in the operating direction. The height of the prong depends on the sensitivity of the label and is usually about 1 to 2 millimeters. The filed prongs must then be polished. If the damage is due to the gripper fingers, first check the penetration of the gripper finger into the pallet notch. If this is too large, the finger damages the label before it holds it. An adjustment of the gripper position relative to the pallet turret at the polygon hub is then required. Too much protrusion of the label on the pallet in the direction of the anvil bar has the same effect. If the label shows bulges near the gripper finger area, check the anvil bar for finger imprints. The discharge star wheel is also often a source of label damage. If the star plates are worn, they will, in the most unfavorable case, shift or damage the labels. The same is true for worn-down wear strips. Faulty labeling, which cannot be traced back to any of the above and which occurs at random, is usually an alignment error of the process components, such as glue, paper, and bottles. The glue, as the most important factor, must not be applied too thickly, since otherwise the label floats, and it can lead to excessive contamination of the machine. Too little glue does not hold the label on the bottle properly, as seen here on the poor glue pattern. After drying, there is the danger that the label will partially or completely loosen itself. The temperature of the glue is also important for correct adhesion. It can be ascertained from the corresponding specification sheet of the producers. Too low a glue temperature decreases the viscosity and leads to poor glue application on the label. consumption increases. Components which are too cold, for example glue, glue roller and pallets, result in the labels sticking to the pallets and therefore causing trouble. Glue which is too warm does not have enough adhesive force and also leads to additional contamination of the aggregate due to splattering. The glue to be used is largely dependent on the machine speed and its processing characteristics. The quality of the glue should be such that it can be applied thinly to the roller and must not splatter. It must be pliable and easy to handle by its processing components. If the temperature and quantity of the glue is correct, the label should adhere firmly to the bottle at discharge. If the label floats, the drying time is too long or the water absorption of the paper too low. The adhesive force can also be reduced by the following: deteriorated glue owing to excessively high glue pump speed. The correct amount at nominal labeler speed is set to minimal return. Frost damage, if the temperature falls below 10 degrees centigrade, and old age due to faulty and long storage. Once again, the exact details can be read off the specification sheet. Paper, our next factor, must combine well with the glue. If the back side of the paper is too smooth, as with lacquering or printing, the drying time of the glue is increased. This also leads to shifting in the magazine. Highly absorbent labels react strongly to humidity and therefore deform when stored incorrectly. Recommended storage conditions are lying flat at about 60% humidity. The labels should be stored at least 8 days before being used. If the dimensions are not within the prescribed tolerance of plus or minus 0.25 millimeters, the label guides must be adjusted continuously. The labels in the stack often stick together due to die cutting or date coding using the code edge machine. So individual removal is no longer guaranteed. In this case, the label should be feathered before being loaded. If the label edges come off again at discharge, check the grain direction of the paper as well as the gluing. A moist label which rolls up from the left and right has the incorrect grain direction. Correct grain direction means that it rolls up from the top and bottom. Apart from the glue and paper, the bottle material can also be at fault in the case of random erroneous labeling. If the bottles vary in their dimensions, such as height, diameter, and shape, a precise centering on the bottle plate is not possible. Too much surface coating, detectable by the bluish glimmer, results in a too smooth surface on which the glue cannot stick properly, just like contamination from conveyor lubricants or aluminium residues from the bottle washer. And the result is badly sticking labels after drying. Now we have covered the most frequently occurring causes of faulty labeling, but we've only touched the tip of the iceberg. To give you further assistance, Krones offers customer-specific and practice-oriented seminars, where we would be most happy to welcome you. Your Krones AG.